Okay, we learned the logarithm and exponential functions, and usually after we do that, and we need to learn how to solve an equation. So this section, we're going to do exponential, and logarithmic equations. We're going to solve equations, which means you try to find the value of x that satisfies the equation. Okay, so let's try that. For the exponential equation, that is an equation containing a variable in an exponent. For example, 5 to the x equals 25. This equation, this x is at the top, as a shoulder, as exponent place, so that's called exponential equation. Okay, so exponential equation, we should know this. If b to the m equals b to the n, therefore this m equals n. Okay, so based on this, if they have the same base, and then the power got to be the same. So in this case, because we know 5 squared is 25, okay, so that x is just 2. Okay, so this is one way. If you have some number looks very, very easy for you, then you can just quickly go ahead and do it. Otherwise, you have to do something else. But let's do some simple one first, and then we go to the complicated one later. Now, I give you this one. 2 to the power of 3x minus 8 equals 16. Pay attention to these two numbers. This is an exponential equation because this x is at the shoulder, it's at x at the exponent. And then here's a 2, here's a 16. Now, we know the relationship between them because we know 16 equals 2 times 2 times 2 times 2, isn't it? 2 is 4, 4, 16. So that's 2 to the 4th power. Okay, so let me rewrite that. This is 3x minus 8 equals, I rewrite this 16 as 2 to the 4th power, and then same base, then the power got to be the same. 3x minus 4, did I say 4? Minus 8 equals 4. And then I go plus 4, plus 8 on both sides. So I get 3x equals 12. I get x equals 4. Done. I solved it. Okay? So this is a very easy example because the number you're very familiar with. Okay? So let's try one more. And then we go to the complicated one. Not that obvious. Okay? 27 to the power of x plus 3 is equal to 9 to the power of x minus 1. Now, what is the relationship between this 27 and 9? Okay, we know 3 squared is 9, and 3 cubed is 27. That's what we know, okay? So let's write this. This is a 3 to the 3rd, then x plus 3. And the right side is a 3 squared, then x minus 1. So the power of a power, you just multiply those power. So that means a 3, and this times that is the power equals 3. And here will be 2 times x minus 1. Hey, we are very lucky because we get the same base. And even the x here is at the exponent, but we can just let them equal and go ahead and solve it. So we are going to solve this. 3 times x plus 3 equals 2 times x minus 1. Distribute 3x plus 9 equals 2x minus 2. I subtracted 2x both sides. So I will get x plus 9 equals negative 2, see? And then I minus 9, so I get x equals negative 11. That's my answer. Okay, so if you try to solve this exponential equation and the base, those are kind of like a simple, easy numbers, and you already know something, so just go ahead and do it and use this. Okay, if b to the m equals b to the n, then this m must be the same as n. But sometimes it's not that obvious. In case it's not obvious, we take log. for example, 4 to the x is 15. Oh my goodness, I don't know how to do it. Because 4 to the first, that's 4. And 4 to the second is a 16, but here it's a 15. So this thing is going to be something close to 2, but now the 2, it should be like a 1 point something, but we don't know. And you don't really need to give me the exact value unless you like. But anyway, how to solve it? You take ln on both sides. You put ln 4 to the x equals ln 15. Do that. Okay. Once you do that, once you put ln, then the good thing is there's a power. You're going to bring that to the front. Remember the property we just learned? So we get x times ln 4 equals ln 15 divided by ln 4. So my x will be ln 15 divided by ln 4. If I didn't ask you to give me the correct answer, give me the answer in the decimal form, this is good enough because I don't think you're going to go ahead and simplify this. But it's already easy enough. If you have a calculator, you can just go ahead and do it. Okay, so if you have some question look like this exponential equation, and it's not very obvious, then what you should do is you just take ln, or you take log base 10. Either way, it should be the same thing. And sometimes you might not want to have a choice. For example, here, okay, 10 to the x equals 120,000. Solve for x. Take log. And this time when we take log 10. So we're going to do log 10 to the x equals log 120,000. All right, and then this x goes to front, and here's a base 10, so that get eliminated. So x will be log 120,000. If you have a calculator, and just go ahead and find out what is the log base 10, 120,000. Then that's how you solve this exponential equation. All right. Okay. Now try something even more complicated. So let's see. Can you solve this? 5 to the power of x minus 2 equals 4 to the power of 2x plus 3. If you don't know what to do, take log. Okay, take natural log. I like to take natural log. This is even easier. So log 5 to the power of x minus 2. Here is the ln 4, and then here is 2x plus 3. The good thing, after I take the log, this exponent, I can bring that in front of the log. So I have x minus 2 ln 5 equals 2x plus 3 ln 4. And then I'm going to distribute this into this parenthesis. So I get ln 5 x times ln 5 minus 2 ln 5 equals the other side. So I get a 2x ln 4 plus 3 times ln 4. All right, now here is x, here is x. I'm going to bring x in one side and then put the other numbers without x to the other side. So I'm going to subtract 2x ln 4 on both sides. Okay, subtract 2x ln 4, and then I go to plus 2 ln 5 on both sides. So I do that at the same time. Okay, or you can do this a step and then another step, but I just do them together. This get canceled and this get canceled. So the left side I have x times something minus something with x. I factor x out. This is the tricky part. I factor x out. I get ln 5 minus 2 ln 4 equals, and the right side I get a 3 ln 4 plus 2 ln 5. Okay, and then in order to solve for x, I just need to divide it by this, just divide it by that. Therefore my x equals 3 ln 4 minus 2 ln 5 over this guy, ln 5 minus 2 ln 4. That's it. That's your answer, because the right side is a number. You can use a calculator to find it. Okay, so this is a complicated one, right? And there could be something more interesting. So let's look at this. E2x minus 4ex plus 3 equals 0. We cannot take natural log, because natural log is not going to distribute that into every single term. No. What you should do is you might want to use the substitution method. Okay? The substitution method is this. We just let e to the x equals, you can just say m. Okay, I don't care, whatever letter. So e to 2x is the same as e to the x squared, isn't it? So therefore, what you have is you got m squared minus 4m plus 3 equals 0. What do you have? You have a quadratic equation. So you can solve for m, and after you solve for m, you can go ahead and solve for solve for x. So this is m minus 1 and m minus 3. You factor that, you get a 0. So m is either 1 or m is 3. Now change back to x. So we go ex is either 1 or ex is either 3. So what is x? E to the x the power is 1. E is a non-zero number to whatever power is 1. That power got to be 0. So in this case, x is a 0, 0th power, right? And what about this one? E to the x equals 3. We take ln both sides, and this is just x. That's ln 3. So you have two solutions. Okay, so this one, even when you look at that, it seems like it's kind of a difficult to do, but it's not that bad, because if you notice that this term is just this term's square, then you can just replace this, and then you can solve the equation. Okay, so everything so far we did is the exponential equation. So shall we do the log equation? Similar idea, right? The log equation, which means, for example, if I ask you, what is the log x equals 25? This is a log equation. Okay, for the log equation, then here is 10, right? It's an invisible 10 here. Oh, it's really invisible. Okay, so it's log 10 to the, if you rewrite that into the exponential form, it will be 10 to the 25th power, and that is x. Done, you solved it. You see that? It's not bad, huh? Okay, so let me ask you a question. Can you solve for log base 4, and here is x plus 4 equals 2. This is a log equation. When you solve that, you rewrite that as exponential form. Therefore, you get a 4 squared equals x plus 4. That's not bad. 4 squared is 16. And that is x plus 4. So I get x equals 12. That's super, super easy. Okay, but, I know you don't want to hear the word but. If you do log equation, you always want to check. Okay, check your log. Check the answer of your log. Why? Because remember, for the log function, this guy has to be positive. So once you have this x value, you bring this back to see whether that will make this thing positive. So 12 plus 4 is 16, positive, done. So after you check, you can be very confident to say, hey, 12 is my solution. Okay, then try one more. 3 ln 2x equals 12. How do you solve for this equation? Did you notice here is just multiplication? 3 times something is 12. We divide it by 3. So we get ln 2x will be 12 over 3, and that is a 4. All right, now we're going to rewrite this in the exponential form, which is e to the 4th equals 2x. You agree? And then we divide it by 2. So my solution is e to the 4th over 2. All right. But before you say that, hey, I got to check. So x equals e to the 4th over 2. I bring back to my original equation. 2x is e to the 4th. Whew, it is positive. So done. Okay, I checked and it's done. So far, so good. Okay, try one more, two more. Okay, so let me do this one. Log base 2x plus log base 2x minus 7 equals 3. This is a very typical log function, log equation. How do you solve that? By definition or by the property, log plus log, which is the log of multiplication, right? Okay, and that equals 3. And next, I'm going to write this as 2 to the 3rd. Base is always the base. 2 to the 3rd is, you multiply this, that is x squared minus 7x. And what is 2 to the 3rd, which is 8. So we have x squared minus 7x equals 8. I bring 8 to the other side or subtract 8 on both sides. It's a quadratic equation. I love it. Quadratic equation, I factor. So I go x minus 8 and x plus 1 equals 0. Can you go ahead and solve it? Yes, either this is 0 or this is 0. So x is either 8 or x is negative 1. Are you done? No. You have to check. Remember, to solve the log equation, you always have to check. How do you check? You bring this x equals to 8, bring it back to see whether you have, you're taking the log for a positive number. When x equals 8, here's an 8, no problem. Here, 8 minus 7 is 1, no problem. So this is good. And what about negative 1? That's not good. Do you see the trouble comes? Okay, so here is a log 2 negative 1. No, no. And this is log 2 negative 8. No, no, no. So even you use this property, at the end you get x equals negative 1. But practically, it will not be a solution. So cross this out. So your answer will be just x equals 8. Be super careful when you work on the homework or quiz or exam. Always check. So there's only one solution. There's only one solution to this. Okay. Another one. Ln x plus 2 minus ln 4x plus 3 equals ln 1 over x. This is a log equation. All right, now this divided by this, right? This log minus log. So I get a log x plus 2 over 4x plus 3 equal ln 1 over x. Log a equals log b, which means a equals b. So we get x plus 2 over 4x plus 3 equal 1 over x. And then we do cross multiply. So this x plus 2 times x, 1 times that, and equal. So x times x plus 2 equals 1 times 4x plus 3. So that is x squared plus 2x, and the right side is 4x plus 3. I move everything to the left side. I subtract 4x, so I get x squared. 2x minus 4x, I get a minus 2x. And this 3, I bring this over, it becomes this. And I factor, okay? I factor that, I get x minus 3 times x plus 1 equals 0. If you think I'm going too fast, you can slow down. You can pause here and read this to see what's going on and follow up. And here, the first solution is either x minus 3 equals 0 or x plus 1 equals 0. So do you get x equals 3 or x equals negative 1? Again, this is a log function. So you have to bring the number back to your equation to check when x equals 3. 3 plus 2, 3. 3 plus 2 is 5, no problem. 3 times 4 plus 5 is also a positive number. And 1 over 3, that's good. So this is good, okay? And x equals negative 1. Negative 1 plus 2, positive 1, no problem. Negative 1 times 4 is negative 4 plus 3 is negative 1. We're all in trouble, no good. And here negative 1, no good. 1 over negative 1 is also negative 1. So this has to be dropped. Now you see why I always ask you to test, to check your solution when you solve the log equation. So there's only one equation, one solution to this equation is this. It's x equals 3, and that's the only one. All right, now we're going to work on just one application for this, and then we're going to finish that, okay? So I'll give you the formula, this. A equals principal, you put in the money in the bank, that's the principal, how much you put. A is the amount, how much money you're going to get at the end of T years. And the bank pays you the annual rate and then compounded, let's say monthly, and that would be 12, right? So here's N, and the T is the number of years. I ask you this. I put in $5,000, okay? All right. And I want to have, I put in $50,000. I have a lot of money. So $50,000. All right. And then I want to have $1 million. Am I too greedy? Okay. So I put in $50,000. I want to have $1 million. And then I know the bank pays me 0.09 interest annual rate. Oh, that's super high. And then they are going to pay me the interest compounded monthly. So N is 12. And here is N is 12 T. So basically I'm asking how long is this T? How much is this T? That means after how many years your $50,000, based on the way this bank pays you, you're going to get $1 million. Interesting question. So I'm going to have 1 million equals 50,000 times 1 plus, actually this is 0.09 over 12, and here is 12t, isn't it? Okay. So I would divide it by $50,000 both sides. If you do that, then that would be 20 equals, if you divide it by that, okay, because all the 4 zeros are dropped, 100 over 5, that's 20. And then that will be 1 plus 0.09 over 12 to 12t. And guess what? I know this. 0.09 over 12 plus 1 is 1.0075 to the power of 12t. I'm looking for t. This is an exponential function, isn't it? Exponential equation. I need to solve for that. So how do you solve it? I take natural log. So the natural log of 20, natural log 20 will be the natural log of 1.0075 to the power of 12t. And the power, the good thing is, it goes to the front. 12t, 1.0075. You're looking for t, isn't it? But those are the coefficients. You just need to divide it by 12 and ln 1.0075, you get a t. So your t is going to be this. Your t is ln 20 divided by 12 ln 1.0075. Okay, if you use a calculator, you're going to get 33.4. That's in years. Okay, so after 33.4 years, your $50,000 will increase to $1 million. Now, you probably notice that because once you divide it by $50,000 each side, you get a 20. It doesn't really matter how much money you put there. It just cared about how many times more money you're gonna get. So it takes a 33.4 years to make your $50,000 investment becomes $1 million, which is the same time 33.4 years to make my $5 deposit to be $100. Just grow up 20 times, just grow 20 times more. Okay, so this is just the one application. I think you're going to see some question in the homework, and then now you know how to do it.